Good afternoon. This session is an opportunity to hear some of our trainees, doctoral candidates, and younger faculty members who have had opportunity to engage in research in a variety of diverse but related fields. Every talk this afternoon is really exciting. Some of them are kind of linked together. Some of them aren't. We're going to stick to a 20-minute presentation for each of these folks, followed by a 5-minute Q&A from the audience. If you have any questions at all, the only place to ask a question is standing at that microphone right there. You can queue up at the microphone if you have several people that want to ask questions, and we'll keep things on track. So, without further ado, our first speaker is Duha Ali. She's a PhD student from Auburn University, focusing on the occupational health and safety of a lot of different folks, but with a real interest and passion for ergonomics. Title of her talk is Evaluating Physiological Effects of Inclined Carrying.
As he said before, my name is Duha Ali. I'm actually in the Department of Industrial and Systems Engineering in Auburn University. I'm doing my PhD, and I'm hoping to graduate within a year from Auburn. So I would like to start my presentation by thanking the Deep South Center for the generous fund that they provided for me to be able to implement these two studies. However, because of the time allocated for this presentation, I'll be only able to present one of these studies. So I'm assuming that most of the people in this room are aware of what musculoskeletal disorders are, or what MSDs are, and how MSDs contributes to escalating the healthcare costs for businesses. It was actually reported by OSHA in 2014 that $20 billion were spent for workers' compensations because of the MSDs. And what was really interesting is half times that amount was spent for indirect costs to rehire people and train them. So talking about MSDs, we thought of designing a study that is related to the manual material handling, because manual material handling environments are known as environments that cause a lot of MSDs, I would say. And then specifically, we want to focus on one-handed carrying as part of the manual material handlings. So we wanted to focus about one-handed carrying because it was observed that one-handed carrying actually has more physically demanding to the human body than two-handed carrying or other carrying methods. For example, one-handed carrying can cause or result a greater spinal compression whenever you do carry with one hand than double the load in two hands. And one-handed carrying requires greater energy expenditure than two-handed carrying by a study that was conducted by one of my colleagues in 2018 and 2019. So despite all that knowledge about one-handed carrying, there is no formal guideline for one-handed carrying in either the International Organization for Standardization or the Liberty Mutual manual material handling tables. So the Liberty Mutual manual material handling tables, for those who does not know these tables, they actually provide a percentage of the population that are capable to do a specific task based on the variables, like if you change the weight, if you change the frequency of the work, or if you change the duration, for example, and other variables as well. So now imagine performing one-handed carrying on an inclined surface or on a ramp, okay? Walking on an inclined surface by itself requires a specialized neural control strategies for you to be able to do it. And we have a lot of work environments where walking on an inclined surface is required, such as agriculture, maritime, construction. Right? So what we wanted to do is actually to have a study to be able to compare the physiological and psychophysical responses within the participants while performing manual material handling tasks, specifically one-handed carrying on inclined surfaces and flat surfaces. So far, we were able to recruit 12 female participants and 14 male participants. We have chosen the age range, as you can see here, the age range for the participants to be very narrow, between 19 to 30 years old. And that is because the aerobic fitness of the human body declines beyond the age of 30. So we wanted people to have like a kind of similar, I'm going to say, cardiovascular health or cardiovascular fitness ability to perform the experiment. We've also, because we know that obesity might be a factor in these experiments when we have to have a physiological effects measured. So we tried to have a wide range of obesity as it is identified by the NIH, the National Institute of Health. It is identified based on the body mass index. So if you can see here my pointer, we have tried to have a wide range of obese people to have a more general population to perform the experiment. Okay, so what we have done is that we had the participant coming to the lab, completed a survey talking about their physical activity routine, because it is important to understand how physically active they are, because we are measuring their physiological responses. And then we had them to do 4 randomized trials. Between each trial, they had only 10 minutes to rest, and they were not allowed to have any food. However, they were allowed to have water and rest. So these 4 trials were actually no load on a flat surface, no load on an inclined surface, load on a flat surface, and load on an inclined surface. We set up the treadmill to be on a fixed speed, so we don't have the speed variable affecting the results. So the speed that was chosen is a 3.2 kilometers per hour speed, which is a walking speed whether you are on an incline or on a flat surface. And we have chosen the incline to be 20% grade, and the loads that were chosen for females and males were different because females and males' body are not homogeneous in terms of their physiology. So the load that was chosen for females was 5.5 kilograms, and for males it was 9 kilograms. Okay, so as I said before, we were interested in having the physiological and psychophysical assessment for our participants. So for the physiological assessment, we have measured their VO2 uptake, the volume of oxygen uptake for the 4 trials. And for the physiological assessment as well, we have measured their heart rate while they're doing the 4 trials. So both of these physiological measures were collected through the COSMIT K5 device, which is the device that you can see in the photo. The mask collects the oxygen and then measures the volume of oxygen and CO2 collected. And then there is a heart rate strap that was connected to their bodies that already syncs the heart rate measurements to the device. For the psychophysical assessment, we've used three different assessment tools: the rating of perceived exertion, the rating of perceived dyspnea, and the NASA TLX scale. So the rating of perceived exertion, it is a scale that goes from 6 to 20, in which you ask the participant, how did you perceive that? So we've used that 2 times after each trials. One, we asked them what was the peak rating of perceived exertion that you had for your whole body, and what was the peak rating of perceived exertion that you had for your dominant arm. And then the rating of perceived dyspnea is actually another assessment tool in which you ask the participants how much difficulty is your breathing causing you right now. And the NASA TLX scale, the NASA Task Load Index, it's actually a scale that has 6 subscales under it, in which we ask the participants how mentally demanding was the task, how physically demanding was the task, how hurried or rushed was the pace of the task, how successfully were you in accomplishing what you were asked to do, how hard did you have to work to accomplish your level of performance, and how insecure, discouraged, irritated, stressed, and annoyed were you. So for the confounding variables, we were able to control for several variables that we thought that are important. First of all, the sex variable, because we know, as I mentioned before, males and females are not homogeneous, so we were not even planning on doing the same analysis for the participants. It's going to be a separate analysis, and we have chosen different loads for both to carry during the experiment. The age range, I've talked about this before. And then for the nutrients, we have asked the participants not to eat 4 hours prior to the study, not to exercise for 12 hours prior to the study, and then not to consume alcohol for 24 hours, and not to drink caffeine the day of the test. We've asked the female participants not to perform the study during their menstruation phase, and we didn't recruit any participant who has a smoking history. So moving forward, as you can see here, the ones that are, I don't know if I can point. Okay, the ones that are in blue are the ones that involves the incline, and the ones that are in orange were the ones that were performed on a flat surface. So the second one from the left, here is the one that has both the incline and the load, the trial that had both the incline and the load, which it was expected to be perceived as a higher exertion. However, what was really interesting to see is that the participants perceived the one with only the incline without carrying the load to have a higher exertion than when they were performing the carrying on the flat surface. And the same thing was observed for their, whenever we asked them about the rating of perceived exertion for the dominant arm. So the first two that you can see here are the ones performing the load. However, the one with the incline, even if it's the same load, it was perceived to be higher just because, for their arms, just because it was performed on an incline. So this is the one that asked them, how much difficulty is your breathing causing you? Right now, the two ones with the inclines are the ones in blue, were also perceived to have a higher exertion in terms of their breathing. This is the NASA TLX load index with its 6 subscales. I'm not going to go through this, but it shows that the same trend has been reported by all the participants. This is the females, and this is the males participants. So for the physiological data, the VO2 uptake or the VO2 volume was also reported to be higher with the trial that had both the incline and the load. However, what was interesting to see is that their VO2 volume was actually higher whenever they performed the incline trial than the load trial, and similar for the heart rate. And the same was also observed for the male participants. So we have conducted an ANOVA, and it has shown that the p-value was actually significant for the load and for the incline, but there is no significance for the interaction between the incline and the load. And when we have calculated the eta square partial, both of them showed that there is a high effect size. However, for the incline, the effect size was much more higher. And the same was observed for the male participants. So something that was interesting that we've noticed is that all the participants were directed not to use the handrails while they are on the treadmill. However, around 38% of the participants used the handrails while walking on inclines that were less than 12 degrees. So I was interested to see whether there is like an OSHA guideline that requires a handrail within a specific degree of the ramps, and actually I was not able to find any guidelines, so this would be something interesting to further investigate in the future. So at the end, what I would like to say is that this is just a baseline of being able to have or develop one-handed carrying related guidelines within like OSHA or within the manual material handling tables. And it would be interesting to investigate other manual material handling tasks on incline surfaces.
Very well done. Thank you. I was curious on your results. You had a lot of variability in your male responses, male perceptions versus your females. Could you speak to maybe why that observation was captured?
Yeah, so this...
Why are the males so variable and the females are not?
Yeah, so I am assuming, this is one of the, why we have collected the physical activity of the participant, but I am assuming this could be related to what their exercises routines are, because all the males, like the female's weight was relatively small. It was like 5 kilograms. The males was 9 kilograms. And I'm assuming this is related to, do they actually exercise, like if they were doing weight training, for example, as their physical activity routine, they might have perceived it as like a small weight or a small load relatively than the others who do not exercise or do weight training. Any other question? Yes.
To add on to that question, did you consider controlling for percent body fat or any sort of body composition measure, like to do an ANCOVA? I'm just curious if that would, since treadmill walking is a load-bearing exercise, that would be my first question. And then the second is, did you consider using an asymmetrical weight versus a symmetrical weight? Because that likely would also change. You know, because a lot of workers that are carrying things in the field aren't carrying a symmetrical weight.
Yeah, so for the weight that we have chosen, so all the participants were actually carrying a weight within, regardless of the weight, the actual weight, like kilograms, I don't know what to say, but they were actually carrying the same dimensional, like the same, it had the same dimensions, all the weights, whether it was like 9 kilograms or 5.5 kilograms, it was the same weight, same dimensions. For males and females, only the value of the weight was different. And sorry, what was your first question? Controlling for the...
For any sort of body composition measure?
Yes. So for that, when we actually started the study, we wanted to have people, so based on the NIH measures or scale, we have people who are less than 25 BMI, 25 kilogram per meter square, are considered healthy. And more than 30 are considered obese. So we actually tried to have 2 categories within each gender or within each sex to be able to compare between them. But then we were not able, unfortunately, to find people who are obese within the age range that we're targeting, which is less than 30 years old. So we decided to go for the age range that is narrow, and we want people who are relatively younger than to go for the obesity and to control for the obesity or fat percentage.
Great presentation. Join me in thanking Duha Ali. Great job. Next up is Blake Scott. Blake is also a doctoral candidate, and her primary interests are in community recovery from natural disasters. Blake hails from the University of South Florida, and her title this afternoon is Employment Impacts and Sector Shifts in the Florida Panhandle post-Hurricane Michael?
It's well documented that natural disasters such as hurricanes can cause economic disruptions, though typically they're brief, maybe a few weeks at the most until recovery efforts are complete and businesses are reopened and people have come back from evacuation. However, in vulnerable populations, they can be prolonged. By vulnerable, we mean those at a greater risk of loss or damage after a disaster. One way that economic vulnerability specifically is measured is by looking at a composite score of local rates of unemployment, education levels, income, and how many live below the federal poverty level. We've seen examples of prolonged economic downturn from hurricanes that have impacted the U.S., like Hurricane Katrina on New Orleans and Hurricane Maria on Puerto Rico. Research from those hurricanes added to the understanding that when economic vulnerabilities already exist in a community before a disaster happens, that they are more likely to have more severe and prolonged economic and employment crises rather than a short disruption. In essence, these communities have less resilience to quickly adapt and bounce back economically. These prolonged economic disruptions don't only affect the livelihood of post-disaster community, they also strongly are connected with the health and well-being of those that survived. At the community level, they can lead to barriers in accessing healthcare and social services if less providers and staff are available, as well as gaps in infrastructure from destroyed and badly damaged hospitals, emergency rooms, and clinics. At the individual level, research has shown that unemployment can cause depression, anxiety, a decline in physical health, and unstable dynamics at home, and worker burnout, all of which are crucial considerations for foundational models related to worker health, such as the NIOSH Total Worker Health Framework. Given Florida's location in the warm waters of the Atlantic and the Gulf of Mexico, as well as its peninsula shape and miles of coastline, it's particularly susceptible to hurricanes. Out of curiosity, is everyone familiar with hurricane categories? I know being in the south with the bizarre, but maybe landlocked Kentucky isn't so much. 1 through 5, starting at category 3, it's a major hurricane, so you get the idea. Okay, good. Since regular hurricanes began being recorded around the year 1900, Florida's had more direct landfall from major hurricanes than any other part of the United States, as you can see by this chart of places that have been hit the most. The red color in that chart represents Category 5 hurricanes, which are the rarest and deadliest and have a wind speed of over 155 miles an hour. There have only ever been 5 of these that have hit the United States since recorded history, and Florida has the distinction of being hit by 3 out of 5 of them. The Labor Day hurricane in 1928, Hurricane Andrew in 1992, and Hurricane Michael most recently in 2018. Because of all this experience, Florida has learned a lot of lessons about hurricane preparation, response, and recovery, and generally we have the resilience to quickly get back to normal within a few weeks. Florida also has a pretty stable and positive economy, due in part to our tourism from things like beaches, theme parks, cruise ports, Super Bowl and NHL winning teams, large cities like Miami, Tampa, Jacksonville. You get the idea. And this is a map of economic vulnerability composite score for Florida counties. The score is calculated by the CDC and ranges from 0 to 1, with the higher the score, the more vulnerable the county. For this map, the darker counties indicate those that are more vulnerable. And as you can see, it can be pretty patchy, but for the most part, the coastal counties are in that lower half. Though if you also notice, there are a couple of concentrated areas. Well, this was the path of Hurricane Michael, Florida's most recent Category 5 hurricane. It went right over one of these pockets of high vulnerability. Hurricane Michael has been dubbed a 1-in-100-year storm, meaning that one like it only comes along once in 100 years. It was particularly surprising how much strength it gained right before it made landfall, as well as that it hit the center of the Florida Panhandle, which usually sees far less hurricane activity than the rest of the state, not to mention how strong it was. To this day, the area is still recovering. Research has noted the public health impacts of this unprecedented stagnant recovery, a few of which have been delays in access to prenatal care and possibly an increase in low birth weight. I was part of a post-disaster community assessment survey that was done a full 13 months after the hurricane, and I took these pictures that you see here. We found that residents were still experiencing income and job loss, problem with substance addiction and anxiety, depression, as well as having to travel further for healthcare and social services. The area's been struggling for so long that several years afterwards, the state of Florida established an economic revitalization program to help bring back businesses, employees, and income to the area. Just last year, a full 3 years after the storm, through this program, they were awarded $60 million. Hurricane Michael was unique in a lot of ways in terms of its force, where it's hit, the vulnerability of the community that it hit, and how long it's taken to recover in a state that typically recovers quickly. And so our objective for this study was to quantify how Hurricane Michael's economic disruption was different from other recent major Florida hurricanes, then to characterize which industries were impacted, and to apply these findings to community and worker health considerations, all for the sake of better understanding how this area can continue to build back better and insight into how they can be more resilient for the next hurricane they experience. We first looked at post-hurricane changes in unemployment for each of the 6 major storms that have made landfall in Florida since 2000 that are listed here in yellow. For this, we used unemployment rate estimates reported monthly for each county to the Bureau of Labor and Statistics. Our challenges with approaching this analysis of comparing these different hurricanes to one another was accounting for different population sizes for each county that experience a Category 3 or higher hurricane conditions, as well as accounting for the typical seasonality trends within the overall general multi-year trend. Ultimately, we went with a difference in differences analysis of unemployment rate estimates, which measures for significant changes in parallel trends pre and post an event, like this example graph you see here. Because Florida's economy has similar annual trends in unemployment across the state, we were able to compare all 67 Florida counties and designate those that had just been hit by a hurricane as exposed, while all others were classified in that time frame as not exposed. We did this analysis for each individual month, comparing the month post-storm to that same month of the previous years. So for example, for Hurricane Michael, we looked at all 8 counties and we compared October 2018 when it hit to the predicted trend of what would have followed after October 2017 compared to the parallel trends of all the rest of the counties. We did this for every month after each hurricane until we found no more significant increases in unemployment. We also tested the sensitivity of this model by performing little kind of placebo analyses, meaning we did that same analysis for years when those impacted counties weren't hit by a hurricane to see if that there wasn't any significant changes. We actually got pretty lucky with this in that when all the hurricanes hit, looking back, we didn't encounter any other economic crises like the crash of 2007. Our results showed a rather striking contrast between the storms. We found that among the 6 major hurricanes that hit Florida that we analyzed, 2 had no following months of increased unemployment. 2 hurricanes had 1 month, 1 hurricane had 2 months, and then Hurricane Michael caused up to 11 months of increased unemployment in 1 county alone, almost a full year. 2 other counties hit by Hurricane Michael also experienced 6 and 10 months of increased unemployment. This is a map of our findings. To give you a little better context, there's Hurricane Dennis that hit over on the far, far west. There was Hurricanes Charlie, which hit on the southwest, Jean, which hit on the southeast, Wilma and Irma both hit on the very, very southwest. And then Hurricane Michael hit where that same arrow was on the map of economic unemployment, right there in the center of the Panhandle. To kind of tie this all back to economic vulnerability, all of the other counties had a score of below of 0.5. So it was only the counties hit by Hurricane Michael that had those really high vulnerability scores that we saw these results. Of all the 16 hurricane-impacted counties that were analyzed, the 2 coastal ones that are the darkest orange that had the highest economic vulnerability, and were also the 2 that experienced the longest period of increased unemployment. Interestingly, the inland counties hit by Hurricane Michael, which also had higher rates of vulnerability, didn't have increased months of unemployment. However, that One county that is kind of like a middle orange color just to the west of the brightest orange, that's the one that experienced 6 months of increased unemployment. And that one, we kind of wonder if it had less months of increased unemployment because it already started out with a lower vulnerability score, because that is Bay County, which is where Panama City is, so hence it's a much larger population, they get a lot more tourism. Now that we had findings that highlighted how unique Hurricane Michael's impact was on the local economy, we wanted to understand what industries were most affected. For this analysis, we used the Bureau of Labor and Statistics quarterly census of employment and wages, which is a count of all employees by industry who are eligible to collect unemployment benefits, which is over 90% of the U.S. workforce, and it's collected annually by quarter. These blue dots represent each of the industry sectors that the employees are organized by. So we can see, based off of the trends, each sector, which ones had a loss of employees after a hurricane. We use that same difference in differences analysis of parallel trends to compare the multi-county metro area of Panama City to another nearby metro area with similar population demographics. We chose to use the metro area for this analysis instead of county, so that it would include the larger economic area of all businesses that might cross county lines and also people that might cross county lines to go to work. We performed the statistical analysis for the total employment count of both metro areas for up to 4 annual quarters past Hurricane Michael, once again using the previous year to set the trend. Furthermore, we created line graphs for each of these industries' employment count over a 3-year period to observe changes in workforce volume. And this is that line graph of those changes of workforce volume over 3 years. And this is Hurricane Michael. The top red line is a trend of overall employment. We just scaled it down to be able to fit into the graph with everything else. We found a significant decrease in employment for 3 out of the 4 quarters after Hurricane Michael. The only quarter that wasn't significantly impacted was the one that included the summer months, that we suspected might have been because some tourism came in and created a few jobs, but then afterwards it went back to below trend levels. Looking at workforce volume by industry, we noticed that some of these industries that employed the greatest number of people in Panama City, as well as essential services, were those that had the most observable changes. To go into a little more about this, the green and orange lines are for the hospitality and retail industries, respectively. Hospitality, the biggest employer in the metro area, particularly doesn't recover to the same levels as before Hurricane Michael. And then that light blue line, that is a steady curve down after Hurricane Michael and levels off to never recover, that's the healthcare and social assistance industry. We also saw how education there in yellow took a dip, and interestingly but logically, the construction industry in the darker blue had an increase, likely to meet the demands of all the damages after a hurricane. We found some very interesting results with this study. And some next steps that we're in the process of undertaking is disseminating our work, not just to conferences, but also to peer-reviewed journals, as well as putting together an executive summary in plain language to give back to Hurricane Michael impacted counties and to send to community coalitions and local government. I've also started working on a study that looks at long-term health impacts after Hurricane Michael by analyzing vital statistics death records. Additionally, we think it'd be interesting to go back to that economic data project and do some further analysis on the employee counts by industry sectors after Hurricane Michael, particularly healthcare and social assistance. Some limitations of this study are when working with economic data, that even though this information has been collected across the nation since President Franklin Roosevelt, that it has a robust methodology, but it's still an unemployment rate that is an estimate, and sometimes sampling in the more smaller rural counties isn't as good. Some limitations with the industry data are that it's a count instead of using a rate that would account for population changes, and after Hurricane Michael, there certainly was some displacement. Additionally, as I mentioned, the industry employee count doesn't include employees that aren't eligible for unemployment insurance benefits. Another brief point to mention is that we relied on the NOAA hurricane reports and the imaging that they gave us. However, when it comes to the older reports before about like 2015, the imaging and the descriptions aren't as good as the more recent ones. This study found that Florida hurricanes impacted by Hurricane Michael experienced far longer economic downturn than other Florida counties hit by major hurricanes since 2000. The counties that Hurricane Michael hit already had existing higher levels of unemployment and lower levels of income and education, which made them economically vulnerable. As with studies that were previously found from other catastrophic hurricanes, such as Katrina and Maria, those pre-existing vulnerabilities contributed to a lengthy post-storm economic crisis instead of just a brief disruption. These longer periods of economic decline have significant impacts on the local health of the economy. For those that are unemployed, they're more likely to have physical and emotional health issues and lead to trouble at home, like more disputes. It was particularly interesting with this study to characterize the increases in unemployment by looking at employee volume in industries, such as a decline in the area's largest employers and decline in healthcare, social assistance, and education, but increase in construction. Each of these fluctuations in workforce can lead to burnout in industries that need to continue providing critical community services, with the other side of that coin being that can then be more difficult for community members to get access to those services. All of these findings and considerations add more evidence to our understanding of disaster resilience, and that by addressing an area's economic vulnerabilities before a disaster and building back better after a disaster, that is far more sustainable and what can help an economy recover more quickly after the next natural disaster. As a take-home message, economic vulnerability is a contributing factor for why this area experienced an unprecedented stagnant recovery, prolonged increases in unemployment, and multiple industries saw workforce shifts after Hurricane Michael, all of which has led to long-term impacts on the health and well-being of the community and ultimately has caused a secondary disaster in the area. Disaster econometrics is a very small field, and even less seen is applying these findings to public health. It's our hope that by disseminating this study, we can help grow that area of research and can highlight how building resilience, like by having a strong local economy, can make the difference in whether or not an area has years of individual and community health impacts and barriers to access to care after a disaster. A special thank you to my co-authors and our funders, and with that, I'd like to leave you with this poignant quote from a disaster resilience researcher. Almost there. That not seeing a tsunami or an economic event coming is excusable, but building something fragile to them is not.
Do you think that economic vulnerability and economic capital are similar, inverse, complementary terms?
Yeah, after the governor's speech today, that is definitely something that I want to look more into, and they certainly seem to be two different sides of the same coin, I would say, but I'd have to look more into it. To be honest, this project was really amazing for me because it helped me dive into the world of economics I never had before, and so I've really grown my understanding of it, so something even more to learn.
Hi. So please tell me if my question is kind of outside of the scope of your study. But so I really like the approach that you took, and I was really curious if you guys looked at all about individual counties or industries' response to the hurricane to see if that accounted for any of the kind of variation in how the return to job and job loss kind of emerged over time.
Did we look at it for this project? No, we hadn't. Is that something to absolutely consider? For sure, especially when you consider some of those counties like Hurricane Andrew, the other Category 5, it hit Miami. Of course, it's going to have tons of resources and tons of availability to be able to help, not alone in general having the state response, but the local one. So even though the area Hurricane Michael hit does have Panama City, it still isn't a really huge metropolitan area. So definitely something to consider.
Yeah, and I think the thing that I thought about was, especially when you're comparing counties who might have fairly equivalent resources, it's interesting to see what is done well and what isn't with what they have to be able to use it in the future. So,
right. And to that, I'll actually go ahead and add that there are some that are even smaller counties that, though they have more economic resilience, the example would be the Keys, the very south there. not a huge population, not a ton of resources there. I actually helped to respond to Hurricane Irma, so I saw it. However, they do have a lot of economic resilience. And with that, they were able to quickly respond. I think they only had 2 months after Irma that they were able to bounce back to normal. So something to also add to it.
So when you were speaking, I kind of kept thinking about North Carolina. And so there's a pretty clear-cut historical reason as to why a lot of certain people are in like kind of flood-prone areas.
Is this the pig farmers?
Yes, yeah, exactly. And so
Yep,
I was
yep.
going to say, I started thinking about, I mean, I don't really know the history of Florida, but do you know anything about like if there was, prejudice when it came to like housing loans or property deeds or anything like that? I'm just interested.
That I would say I have not looked much into, but particularly those counties where Hurricane Michael hit, there's a reason why it is a concentrated area of economic vulnerability, that there is a lot of it there. So I would not be surprised if there was evidence of a history, just kind of anecdotally. Growing up in Tallahassee, I can tell you that yes, but I would want to do more research on it. So I
Yeah,
would say that
pretty
that's another
interesting,
factor
yeah.
to consider.
Our next speaker is Michael Saman. Michael is a faculty member at the University of Kentucky. He is in the kinesiology and health promotion program there. Can everybody repeat after me? Hip. Hip joint. Come on. Hip joint. Hip joint gait. Come on, guys. Hip joint gait. Hip joint gait mechanisms, bone health, and pain-related outcomes in farmers.
That was a very entertaining introduction, so I appreciate it. Get everyone engaged. So just to clarify, the picture that's on the website of me is before I shaved my head. So if you get a little confused, I shaved my head a couple months ago. It was starting to go, so I figured Christmas time, no one's seeing it. So it worked out well. So I've kept it, or not kept it, lack of terms. So thank you for the introduction. I appreciate it. Again, my name is Mike Saman. I'm an assistant professor at the University of Kentucky. My primary appointment's in kinesiology and health promotion, but I also have joint appointments in orthopedic surgery and biomedical engineering. And I'll tell you a little bit about myself too, so there's some context to this talk, because probably a little bit of an outlier in this group. So my background's actually in biomechanics, so my PhD work was in mechanical engineering. I did a lot of gait analysis, modeling and simulation to understand muscle force production. Things we can't measure in the gait lab, we can do in silico or via computer simulations. And then I did a postdoc at the University of California in San Francisco, where I learned a lot about imaging, specifically in the hip and knee joints, where we're doing, I learned a lot about clinical types of images. So if you go and get an MRI done, this is what the radiologist will look at. But we also have these specific types of research sequences where we can look more at the composition of cartilage. So we can look at earlier biomarkers of disease, joint degeneration, where we use different types of mapping techniques called T1R and T2 imaging. So my lab at UK has basically taken all these modalities of advanced modeling and simulation, engineering-based analyses of biomechanics, combined it with imaging to really understand this kind of mechanistic approach to disease onset in these populations through gait interventions down there, or how we can intervene using rehab and gait interventions to stop disease progression and pain. So that's a little bit about what we do to kind of give you some context here. So I grew up in New Jersey, the Garden State. There's not many gardens in New Jersey if you haven't been. So I honestly, when I came to Kentucky, it was a culture shock for me. Horse farms, a lot of farms and stuff. So it was really interesting. And then, diving into this pilot project, I did some research before I applied, and come to find out, obviously, we all know that hip osteoarthritis is basically the breakdown of your hip joint cartilage and bone, and it results in severe hip pain and dysfunction. So basically, it's a debilitating condition. Reading some of the papers from like the 70s and 80s, though, what people have found was that there's a high physical demand, as we know, endured by farmers and agricultural workers, which places them at a higher risk of developing hip OA. So this is the interesting part, and this is what I found really interesting. is that farmers are at a 60% higher risk of developing hip OA than the general population or any other occupational activity. That's really, really interesting to me as a researcher in the osteoarthritis realm. And that, I remember something like, it's just within 1 year of working on a farm, you're already at a 50% higher risk of developing hip osteoarthritis. So that tells you a lot about the mechanical demands that these people who work on farms and agricultural workers endure on a day-to-day basis. So if we look at some of the financial aspects of this, hip osteoarthritis results in approximately $170 million in lost agricultural productivity. So that paper is from 2007, or that citation. I'm sure that number's probably increased between then and now. It's been about 15 years. It's still really high. So, but the interesting part to me as a biomechanist is, we don't understand the biomechanical, or we don't know what the biomechanical and physiological factors associated with risk of hip osteoarthritis in farmers is, right? Because if we understand the mechanics that lead to these detrimental effects on the joint level, we can work with physical therapists, athletic trainers, sports medicine docs to come up with interventions to help slow down the progression of disease and pain in these farming populations. So just a little background on hip OA. So people with hip OA walk differently compared to those without hip OA, as we would imagine, right? But more specifically, hip OA people, or people with hip OA, they walk with a higher amount of hip flexion. So basically bring your hip up towards the pelvis, right? So higher amount of hip flexion and lower amount of hip extension. So they're keeping their hip in a more flexed position as they walk throughout the whole gait cycle. They also utilize a gait strategy that employs a higher amount, what we call the internal hip extensor moment. So when we talk about the internal hip extensor moment, think about your glute max, so like your butt muscles, right? So those muscles, there's a larger demand on that musculature during gait in people with hip OA. So you would think larger demand on the muscles, yeah, your muscles are working more, that's a good thing. Not necessarily, right? Because you're changing the patterns, the loading patterns within the joint, which might be really bad for your joint long term. Think about how many steps you take in a day. And if you have this abnormal gait, that could be pretty bad long term. Interestingly enough, this hip flexion, so as you keep your hip in a more flexed position, so previous work from my old lab, my postdoc lab, what they found was that a higher amount of hip flexion at baseline results in a 10% increase in hip joint degeneration over an 18-month time span. So a year and a half, you're already at a 10% higher risk of developing some sort of radiographic-based measurement of hip OA or just a degeneration. And then in turn, abnormal joint loading, that results in poor hip cartilage and bone health as well. So people with hip OA exhibit more severe cartilage damage than the healthy population, which is kind of what we've been talking about. But also if we look at the bone, right, the hip, the actual femur itself, prior work, and this was not in a farming population, just people with hip OA, the general population, they found higher bone mineral density, or BMD, of the femoral neck, was associated with a 57% higher risk of developing hip OA. That's pretty large too. So there's this physiological and biomechanical aspect to hip joint disease overall. So what was the point of our study? So what we're trying to do is to assess gait mechanics, muscle strength, bless you, and femoral bone health in farmers compared to the general population, or non-farmers, is what I'll call them in here for lack of better terms. And I'll talk you through some of our methods here. So basically, we just recruited a couple farmers and agricultural workers from the local Lexington, Central Kentucky area. And then we had a pretty nice healthy control database of basically grad students who are non-farmers, haven't worked on a farm. But the nice part about this control group was that they had no radiographic or clinical signs of hip OA, so no hip joint degeneration or hip pain. And then we also asked them on the day of testing across their whole lower extremity, hip, knee, ankle, if they had any pain as well, and they were pain-free on the day of testing as well. So pretty clean, healthy control population. Each study participant in this pilot study underwent an anterior posterior AP pelvic radiograph, so basically an x-ray of your pelvis, so we can assess radiographic signs of hip OA. And then they underwent a 3D gait analysis, isometric strength testing of the hip and knee musculature. Each participant in the study also had a DEXA of their pelvis, a dual femur DEXA scan. And then they also completed the Hip Disability and Osteoarthritis Outcome Score, which is called the HOOS. We call the HOOS. It's a survey that has different subscales relating to hip pain, hip dysfunction, quality of life. But we really just focused on the hip pain subscale here. So our strength testing and our DEXA methods. So like I said, all participants underwent isometric hip and knee flexor and extensor strength testing. So basically we tested the glutes, the hip flexors, the quads and hamstrings here, and all we're looking at is peak strength. So how much strength can those muscles produce? So a pretty simplistic approach to understanding strength. And then every participant underwent a DEXA of both their femurs, and then they completed the HOOS, like I said. So the HOOS is kind of like a test score. 0 is really bad pain, 100 no pain. So you want to get a high score, basically. And these are just some images here of the different testing positions for our strength measures. And then might be a little hard to see, but this is a picture from the DEXA scan of one of the femurs. And there are some limitations with our current modalities of using DEXA imaging, and I'll talk to you more about some ideas that we have and capabilities that we're going to use down the road with these images. So our gait analysis, basically we just had all our participants walk at a self-selected speed on an instrumented treadmill. And then we just looked at peak joint angles, range of motion, and then moments. So when I talk about a moment, I'm talking about joint loading. So how much load the joints is being applied to the joint here. So we looked at the peak hip flexor and extensor angles, range of motion, and then also the moments. So everything's sagittal plane, so I kept it pretty simple here, and just sagittal plane mechanics. Similarly, for the knee, we looked at peak knee flexor and extensor angles, range of motion, and moments. Oops. The ankle, so ankle plantar flexion, right? So as if you're driving, ankle plantar flexion and dorsiflexion, range of motion and moments. And then we also looked at the vertical ground reaction force, so basically the impact force as you walk. So far, we've collected or tested 4 farmers and 6 non-farmers. And the farmers, as you can see, were significantly older compared to the non-farmers. Like I said, we basically tested grad students. So they're all in their kind of mid to late 20s. But they're same BMI, similar BMI, similar sex distribution here as well. But the interesting part is, if you look at this column here called the KL score, so the Kellgren-Lawrence grading, that's how our radiologist scores OA-based severity here. So a 0, KL of 0 is basically really clean hip or joint, right? No signs of osteophytes or any type of damage. But the farming group, 3 of them had a KL1, which is classified as doubtful hip OA. So the radiologist not 100% sure. He or she thinks there might be something there, so they classified as doubtful. And then 1 person had a KL of 2. So just also a caveat here, this is just a unilateral analysis, so our x-rays and our biomechanics data are collected bilaterally as well, so we can always come back and assess bilateral samples here to increase our sample size too. Walking speeds were similar, and then also interestingly enough, the farmers didn't really report much pain, hip pain here. I think there was 1 out of these 4 that actually had a score of about a 70 or 75. So it kind of speaks to, my thought is more of a resilient psychosocial aspect here, which is another area that we're diving into as well. We have some surveys that we need to analyze on that aspect too. So looking at their strength, there were no differences in strength. They all had similar strength, and this is, like I said, just peak amount of muscle production, torque production that the muscle group can produce. But what was really interesting was that the farmers exhibited a lower bone mineral density of the femoral head here. And so here are the values. So basically, it's about a 0.3 grams per centimeter cube difference here. So lower femoral head BMD. So take it as, so I don't know if bone remodeling basically, so that means potentially, the bone isn't creating as much bone tissue there, and it's kind of breaking down bone more so than building bone in the farming population. So when we look at the joint kinematics, so just angular position, so the hip, knee, and ankle joints all across both groups were similar during the stance phase of gait. So basically heel strike to toe off. And then also the range of motion were similar between groups too. So from an angular position across the whole lower extremity, they're walking the same, which is really interesting. When we start to look at more of the loading, the moments here, and so I put this here as reference. So if you look at the red leg here in this diagram, so basically 0 corresponds to initial contact here, and then 100% is basically at the point when your toe is coming off the ground. So initial contact to toe off. And so what we find here is that the farming group produced a higher hip extensor moment here compared to the non-farmer group. So if you imagine walking, as your foot hits the ground, your glutes are basically activating, right? All those muscles on the back of your hip are trying to produce a rotational force to keep your legs stable. So the farmers are applying a larger demand of those glute musculature during the initial portion of gait here. At the knee joint, what we found is that during the first half and then the second half of stance here, the farmers are applying a higher knee flexor moment as well. So basically the hamstrings, there's a larger demand on the hamstrings during the whole stance phase of gait here as well. And at the ankle, we find this difference kind of towards at the end of stance, right, when you're about to toe off. But the farmers have a larger plantar flexor torque here compared to the non-farmer. So basically the gastrocs and the soleus, the calf muscles, there's a larger demand on that musculature. So if you can kind of see the pattern here, it kind of goes glutes, hamstrings, calf muscles, kind of that whole posterior chain in the farmers that's really has a huge demand on that musculature, which I find kind of interesting. And then when we look at the impact forces, so as you hit the ground, you have this kind of double hump of the vertical ground reaction force during walking. So you could clearly see here that the farmers have a higher peak during the first half and second half of stance as well compared to the non-farmers. So basically, they're hitting that ground with a larger impact force and walking with that larger impact force during the whole stance phase of gait. And that could potentially translate all the way up, and it helped to explain why there's a larger demand on those posterior chain musculature in order to support that load. So is there really altered gait patterns in farmers? I don't know, it's a small sample size, but we're hoping to kind of grow this sample and figure this out. But basically what we've shown here is that this larger hip extensor moment places a larger demand on the hip musculature, like your glute max, right? And so hopefully this figure kind of helps you understand what we're talking about when we talk about these moments. So the hip extensor moment is basically the musculature that causes your hip to go back into extension. A larger knee flexor moment in farmers, so a larger demand on the hamstrings basically. And then a larger plantar flexor moment, so a larger demand on the gastrocs and the soleus here. But then also, like I said, this could potentially be driven by this larger impact force, right? So there's hitting the ground harder and walking with larger forces throughout the whole stance phase of gait. And so what is this relationship of gait patterns with strength and bone mineral density? So you would think they would have to have some sort of altered strength, right? That's what's kind of leading to these gait abnormalities. But we showed that the strength patterns are the same. So there's other factors, potentially neuromuscular factors, rate of torque development, so how quickly they could produce force in the muscle, and motor control aspects here that may be affecting that, but that's kind of complicated and stuff that I don't know too much about, the motor control side, so hopefully you can figure that out with some collaborations down the road. But peak strength, we can say right now, is not really associated with the altered gait patterns that we see in this study. The lower femoral head bone mineral density, so prior work has shown that through some cadaver work and bone explant work, that lower femoral head bone mineral density is associated with lower compressive strength and stiffness of the femoral bone. So if we think about this, right, so the bone can't take as much load, right? So lower femoral head bone mineral density in farmers, so lower load that the bone can actually take, plus this higher hip joint loading that the farmers are utilizing during walking, may lead to excessive hip joint cartilage loading, right? If the bone's not taking the load, some other tissue has. The other tissue that's going to take it is more than likely the cartilage. And over time, the cartilage is going to start to break down and to wear down. So this could potentially lead into the hip OA, And we just saw with radiographically that these farmers do have signs of hip osteoarthritis. And so that's basically kind of what I just said there. So future work, like I said, we use a lot of engineering-based techniques and modalities in our work. So the next step is to use some advanced musculoskeletal simulations to basically look at individual muscle force contributions. So these models and simulations let us look at specific muscles like the glute max or the vastus lateralis. And that's kind of interesting because then you can kind of see on a muscle by muscle level what muscles are really not working properly. So then that can directly help us to develop these targeted and therapeutic interventions to really help farmers walk better or to perform their tasks better. We can also look at more sophisticated models or measurements of contact forces or loading, right? So we can look at the actual intra-articular contact force at the hip joint using these types of simulations as well. So this is all stuff that we can do relatively easily in our lab. So like I said, I did a lot of imaging during my postdoc work, and we do a lot of imaging in our lab. So hopefully in the future, we can get some, a larger pilot data set out of this project, and then use that as pilot data to some sort of NIOSH mechanism to be able to use these more advanced, earlier and more sensitive techniques of hip joint disease or measurements of hip joint disease through imaging to understand what biochemical or what biomarkers are associated with some of these biomechanical markers in the future. And then also, like I showed you, DEXA usually, you do the scan, the system tells you, hey, this is the bone mineral density in this area. So we really want to take a kind of more advanced and quantitative approach. We're all about numbers here, right? I'm an engineer, I'm a nerd, so I like numbers, right? But what we really want to do is map out, and you can see this kind of, we call a color map of the DEXA scan. So this is just someone's DEXA scan, and I just wrote some code to do a color map of this DEXA scan, basically. So from 0 to 5 here, 5 being high BMD, right? So you can just see these areas here of high BMD or low BMD. And what we really want to do is be able to divide the femoral head into quadrants so that we can kind of understand where throughout the joint we see these abnormal areas of bone mineral density and how that relates back to our biomechanical parameters. Again, helping us develop these targeted interventions in the future. So with that being said, I'd like to thank the SCAHIP for the pilot funding for this project. I was also funded through a KL2 award, which helped me out to get this dedicated research time for a lot of the projects I've done so far. UK Research and Creative Activity Award that helped to fund a portion of this project too. My co-investigator, Jody Clacy, faculty over in kinesiology, she's been awesome to work with. She's been a good mentor and everything. And then obviously all the students and undergrads, grad students that helped me out with all this work.
I was curious, I know you have a small sample right now, but if you were to age match, because the age range is a little bit different there, do you think that, or if you have norms for bone mineral density for specific ages, do you think that it'd be different for farmers if you had 40-year-olds for your control match?
Yeah, so the age was different. I kind of just did a general analysis to show the trends. I didn't adjust for it here. I think the biomechanics would still be similar because those differences in the loads were so different regardless of adjusting for age or not. And then as far as the matching, we are starting to recruit a more elderly population into some of our other work in the lab in hip osteoarthritis. So we can always come back and match them to that and see, if, the gait patterns and bone mineral density and stuff, strength are different as well.
And then I have a follow-up question. As far as the increased loading that you were mentioning, wouldn't that be suggestive maybe of more bone formation because you have greater ground reaction force?
So that's a really, really good point. That confused me at first because you would think that the bone would remodel more, right, to be able to take that load more. So my thought is, and it's completely hypothetical, is that over time, these farmers are walking with this abnormal altered gait pattern. So over time, the bone's just I don't know what to do anymore. I'm getting tired. And it just kind of starts that whole remodeling process, osteoclastic activation just craps out somehow. So I think there's a bone pathogenesis to disease here as well. So it's really interesting.
So can this audience take a guess at why these farmers are so different and that their osteoarthritis levels are?
Yeah, and just like I said, this is walking. Walking is a super, super simple task. It's not really highly demanding on the joint either. So if we're seeing it with something with that type of loading, like walking, all the other tasks and things that farmers do, I'm sure it'll be super exacerbated.
Can anybody venture a guess as to why farmers specifically might, for the simple task of, you're at a microphone, you tell me. I'll fix you for standing over there.
What is the question?
The question is, why are farmers more vulnerable? Why is their osteoarthritis level so much higher in a study where we're just looking at you walk and you walk. You're a farmer and you're not. These guys have a much higher level of physiological stress outcomes relative to bone and cartilage deterioration. Why is it so different?
I think he's got an answer back there.
Dr. Bernard.
You just asked me 3 questions.
haven't written a paper on it. I'll have to refer you to it. I suspect that the farmers are not walking on good flat surfaces. So they're getting impact loading and probably for other parts of their jobs where there's a greater extension or flexion of their joints. And those are associated, and rotation under load. And those are all things that probably characterize them over the general.
Absolutely, and I think footwear as well. So everyone wore same pair of sneakers, standardized sneakers during testing here. So yeah.
I'm just wondering.
What my answer was, or?
Sure. I'm wondering would you like to belly up to the bar here?
Sure, I'm happy to. And it relates to my question, actually, as well, I would say, is that not all farmers are created equal. So a dairy farmer has a very different set of tasks than, say, a crop farmer would. Or if you're into horses, which we might be talking about tomorrow, also very different task. So I would agree with the surface, slippery surfaces and uneven surfaces. But if you're in dairy, you're on concrete all day. If you're in swine, you're on concrete all day on your feet. But if you're in poultry, you're not as much. So different environments would be my venture. So my question was actually, who are your farmers?
Yeah, so I thought you were going to get there. So it was 1 cattle farmer and then 3 crop farmers.
What kind of cattle?
I'm a Jersey boy. I honestly, no, I don't remember off the top of my head.
So
The jerseys, right?
Yeah. No, I honestly don't remember. There's locals out in Jessamine County, so kind of close to us. But yeah, I don't know, honestly. Sorry.
Thank you.
I was thinking that, if for crop farmers, you know how they make a living? You pick so many baskets of this, so many bushels of this, so many bags of this, you get paid so many cents per bag, per bushel, per package. So the way to make money is you walk faster. They move really fast. I would imagine that to do that, you're going to take, no matter what your stature is, you're going to take a longer relative stride to try to move faster, perhaps. And could that possibly be related to that overextension, the way you were describing it, be related to this phenomenon?
Potentially. We didn't see any differences in walking speed here, just their self-selected natural walking speed, but we didn't look at any of those spatiotemporal parameters like stride length and stuff like that. But yeah, definitely worthwhile to look into. So.
Wayne?
Yeah, my question is on clearly the numbers. It'd be great to get your numbers up, but I'm wondering, we do a lot of outreach. We go out to all kinds of different venues. We do pulmonary function testing, hearing testing, mental health, suicide, depression issues. Can you take this show on the road? I mean, it wouldn't be something you can do like an hour or two in your laboratory, but is there something that you could do that would help you predict issues that you could do in maybe 15 minutes?
Yeah, so we do have accelerometers in our lab, which we can basically set up and utilize out on the field. And then we just have to write some algorithms to post-process that data. I think Michaela has some expertise in doing stuff like that. But yeah, we could definitely do it out on the field or in the farm relatively easily.
So you did bring it up. The footwear is obviously a big thing because you usually are wearing steel-toed boots on the farm, right? So it's a lot heavier. So how do you, first off, how do you think that would affect if you had them wear steel-toe boots instead?
So as we normalize, I forgot to mention, we normalize this peak force by body weight, so everyone's on the same playing level, right? So we can compare apples to apples. And even though they're wearing sneakers, right, they're still impacting the ground a lot harder. And I think a lot of it's just a conditioning thing, right? It's like a learning thing, right? They're so used to walking with boots that they're going to hit that ground harder as it is. So it could have been something like that potentially.
Do you hope to use qualitative CT instead of DEXA in the future since we're moving towards PQCT and CT scans for bone health instead of DEXA?
Yeah, it'd be nice. It's more expensive, but it'd be nice. Even with the MRI, the technology is getting so nice that we're getting these really pretty bone images, such thin slices that we can kind of see all these altered bone deformations as well. So.
And then I was going to ask about the slipping factor, like muddy conditions, and also have you asked them in your survey, did you ask them about what they're doing every day in terms of, we see a lot more farmers are using gators and four-wheelers to get around. They're not walking as much.
Yeah.
And especially with the larger farms, which we already talked about, the farms are just getting bigger because of how
Yeah.
agriculture is.
The hard part with gate labs is we can't replicate a lot of these tasks in the lab, right? And if I get the lab really dirty, I'll get yelled at as well by my collaborators. But yeah, I mean, there are limitations. Walking is not the most conducive task to study in this population, like I mentioned, but it's a start, I think. But yeah, if we can find better ways of replicating these types of tasks, even like trying to get into the tractor in the lab, if we could do something like that, or even go out in the field with these accelerometer-based measurements or IMUs, then we can definitely tease that apart.
Especially if you look at 2D, like dartfish data with it, probably with the sagittal plane plus the accelerometers in the
Yeah.
field, especially in the slippery conditions.
Yeah, it's more realistic. That's a good point.
Great work.
Thank you.
So additional questions, you can hold them for Mike Simon afterwards. You can find him at the reception. Let's give a round of applause.
Thank you.
Thank you so much. Our penultimate speaker is Katrina Conan. Katrina Conan is from the University of South Florida. She is a doctoral student focusing on occupational health psychology, right? So the softer tissues here. And the title of her talk is Compound Threats Impacting the Emergency Management Workforce.
As I was so kindly introduced, my name is Katrina Conan. I'm a doctoral student studying industrial organizational psychology. So rather than having kind of a more numbers-focused talk, we're switching more into some qualitative research. So just an overview for my talk today. I'll kind of walk you through the context of when we gathered our interviews, informations. At the time, we gathered our interviews between May and June of 2020, so kind of at the very beginning of the pandemic that we've all kind of grown used to. We conducted a qualitative exploration of stressors that were exacerbated by the COVID-19 pandemic and 2020 hurricane season, and then I'll get into a little more detail on our findings, future research, and applied directions. Just a quick refresher on kind of who our population was. We're really interested in looking at frontline responders, emergency management personnel, disaster response, kind of whatever name you want to give them. These people are responsible for anticipating hazards, addressing vulnerabilities, preparing and responding to disasters in their communities. So this could be shelter staff, emergency managers, and the tasks that they kind of do on a day-to-day basis in a sheltering event or after a disaster include immediate life-saving measures. This could be evacuations, leading those, or search and rescue, as well as general public assistance measures, so distributing clean food and water to people, or removing debris, clearing electrical lines that have fallen, et cetera, et cetera. And for context, just kind of the state of emergency management in this time period of May and June 2020. These individuals responded to the most active hurricane season on record at the time, in addition to responding to the COVID-19 pandemic. These co-occurring threats necessitated rapid changes to individuals' job demands to respond flexibly and adaptively to community needs. And unfortunately, at the time, these changes were not well understood. So this project was kind of meant to illuminate how those changes impacted the workforce and what could be done to improve for future years. So we drew largely from the job demands resources model. This is pretty popular in IO psychology. And this model generally assumes that each occupation has specific risks that are associated with the experience of job stress. And these can be categorized as either job demands or job resources. And if an individual has more demands than their resources can sustain, increased amounts of stress and burnout may result. So during the 2020 hurricane season, emergency management personnel likely experienced increased demands and stagnant resources as their organizational structure of disaster management was changing. One type of demands and stressors that we really focused in on for this project was chronic stressors. So chronic stressors can be classified as persistent or recurrent difficulties encountered in life and the workplace. So understanding the chronic stressors emergency management personnel face during kind of normal operations and how they've been impacted by the co-occurring COVID-19 pandemic and 2020 hurricane season can add to the understanding of how to best help these understudied workers. And this brings me to our first main research question, which took an inductive approach to identify the major chronic stressors emergency management workers faced in preparation for a disaster threat. And we were really concerned of what the novel or exacerbated chronic stressors were that were faced by the disaster response workforce during the 2020 hurricane season. In addition to chronic stressors, we were also interested in acute stressors, which disaster response workers faced, particularly navigating the effects of COVID-19 on a sheltering event at this time and sheltering protocols. The COVID-19 pandemic brought about a necessity for change in practice and procedure during a sheltering event. And acute stressors can be categorized as extreme and unusual external stimuli that are perceived as threatening. So I think COVID fits pretty nicely into that description. And this brings me to our second research question. These changes in demands and procedure really prompted this second research question to assess the acute stressors, both novel or exacerbated, that this workforce faced in this 2020 hurricane season. And then, as we were really interested in these exacerbated stressors, we were also interested in seeing what kind of support these workers faced. So additional psychological resources may be needed to minimize the negative impact of exacerbated chronic and acute stressors on emergency management employees' mental and emotional well-being. Perceived support from colleagues and employers has been related to reduced stress. So we were really interested in what kind of resources and support that the organization could offer these workers to help mitigate their stress. And this brings me to my third research question and final, where we were interested in what are the gaps in support that are needed to protect the emotional health of this workforce, and what resources can be leveraged to fill these gaps. Moving on to our method, in May and June of 2020, or May through June of 2020, a Converge NSF working group met via 6 Zoom calls to discuss several issues related to the COVID-19 pandemic and disaster response. The goal of these calls was to discuss strategies to best support vulnerable populations, logistical planning for the upcoming hurricane season at the time, and the potential impacts on the psychological well-being of shelter staff and volunteers. On this call, there were 134 registrants from 15 states, 7 universities, and a host of disciplines that ranged from public health to social and applied sciences, medicine, public administration, public policy, and psychology. So a host of subject matter experts was contacted for this talk. In the call that we analyzed for this study, participants discussed 3 main questions, which were what are the most pressing psychological concerns for shelter staff, volunteers, and clients for the upcoming hurricane season? How are these concerns exacerbated by COVID-19? And then they were also asked what resources are needed to support shelter staff's well-being and psychological health, and what are the barriers to accessing these supports, and how can they be overcome? We utilized open discussion consensus coding, where each of the transcripts was independently coded, and the researchers then discussed each code to reach agreement and to refine the code book. All code discrepancies were thoroughly discussed until 100% agreement was reached. 3 researchers, including myself, thematically coded these transcripts using MaxQDA software. We had 5 main parent codes, which were developed and refined by reviewing the workshop discussion questions and transcripts, which were burnout, organizational support to try to get at the gaps in support or existing support, stressor, which kind of covered the chronic and acute stressors, coping styles, and stigma. Getting into our results, when discussing the chronic stressors that they were facing, participants brought up common themes around the changing nature of the public health workforce broadly, concern for their own family's safety around the virus, and societal issues that impact what happens during a sheltering event. Chronic stressors were most often brought up on their own, but when participants were discussing multiple themes at once, chronic stressors were most often brought up at the same time as gaps in mental and emotional support from the organization. So getting further into the issues in the public health workforce, one participant said, "I think we've tended to push that to the background as other things have taken priority. When you look at a public health workforce that's been reduced, and we're all doing more with less, that adds stress just to your everyday job." So this really sheds light on a larger issue in the workforce, indicating that public health and emergency management employees don't have adequate resources to complete their job requirements. These resources could include adequate personnel trainings, having enough people to do all the jobs that they need to do, and access to mental health professionals. Another chronic stressor that was often brought up was larger societal issues impacting sheltering. One person said, "I guess the other concern could be not just related to the hurricanes and COVID-19, but about the moment that we are in right now, the racial relationships and the impact of that on police as well as the evacuees and how we're going to manage these possible tensions between the police and the public." At the time of the workshops took place, the Black Lives Matter movement had gained traction after the murder of George Floyd, and the tensions between public, police, and government were at the forefront of people's minds. Protests were occurring throughout the country and across the globe in response to systemic racial injustices. So this heightened attention towards policing raised questions about the role of police in evacuation shelters and how these employees would kind of mitigate those potential tensions between the public and the police. Moving into acute stressors, participants brought up concerns about taking COVID-19 home to their families, having enough personal protective equipment for shelter staff and clients, enforcing mask use in the shelter, and what unknowns there would be in the shelter setting, and the impact that would have on volunteers. Acute stressors were brought up often by workshop participants, and were often discussed in relation to burnout when they were discussing multiple themes at once. So in bringing COVID-19 home to their loved ones, one participant said, "Then, of course, with this COVID-19 issue, we have the concern about if I serve like I'm supposed to, am I going to get sick? Am I going to take the illness back to my family? Am I going to die? Is someone that I love going to die?" And that just adds to all the normal concerns. So this fear around bringing COVID home to their loved ones or getting the virus themselves was a pretty notable theme at the time. Another acute stressor was PPE concerns or personal protective equipment, where one participant said, "With all this stuff going on, the expectations are really different, and managing expectations and keeping staff safe and not knowing exactly who will show up and if we have the right PPE. We don't even have the right data yet about if a face mask protects you, if a face shield is required, if a gown is required." So at the time of these focus groups, the best practices for mitigating COVID-19 were still being regularly updated. So the emergency management personnel in charge of running these shelters had to stay up to date on the latest CDC guidelines and incorporate those recommendations into their plans. So things were constantly changing, and they had to kind of adapt with them. This also brings up concerns about inadequate staffing, whether they'll have enough people to do all the tasks that they need to do. And then our last predetermined major theme concerned or explored gaps in support that were needed to protect the emotional health of the emergency management workforce. Gaps in support were the most common topic discussed by the workshop participants. So from this major theme, we had three main themes that were discussed. Inadequate existing training, a lack of mental health tools or resources, and inadequate staffing that leads to issues for the individuals who are working. Concerning inadequate training, one participant said, "We don't set them up with any special skills for that. We do a shelter manager training and we talk about some of those things, but I can't say we're really able to give them a skill set or good enough tools to deal with some of the things that they may have to deal with." Other participants elaborated on this point at times where they said that new staff and volunteers were expected to get caught up on their roles and responsibilities with kind of like on-the-job training. Lack of training like this may lead to confusion about what tasks an employee is meant to complete, adding to potential overall felt stress. Additionally, the lack of support in particularly mental health and staffing was another topic that was often brought up. Inadequate staffing can lead to a host of other issues down the line, including stress, turnover, and burnout, where one participant said that with public health, it's difficult to find people that care enough and are dedicated enough and have these skill sets that we need without losing them unnecessarily. We really, really need resources to be able to help these folks be able to cope with whatever they're dealing with, which again brings up the job resources that are necessary to meet those job demands. Solutions to these gaps were brought up with suggestions largely including additional resources for both mental health as well as logistically planning a sheltering event, understanding roles and expectations, and improved communications between counties, states, and federal and state organizations. And then as we were coding, we noticed some interesting additional themes, particularly around burnout, but most interestingly around stigma, where one participant said, "But I think the biggest issue everywhere, and that's stigma. You don't want to be the person in your workplace that comes out and says, 'This is too mentally stressful for me.' Even though people will say that, they're not going to say it right out loud. They're not going to say it in that direct way." So the idea of asking for help in some way would show weakness was often brought up by participants, and this stigma around asking for help and the fear of being reprimanded. Which, this is a long quote. I won't read this one out loud all the way. But this was a sentiment that was brought up multiple times throughout the breakout groups and the workshops. There was a fear that asking for help with one's mental health would be used against them. And this may be because of the culture of emergency management as an occupation. Participants often expressed that burnout and poor mental health were kind of just part of the job and were to be expected occupational hazards. So, overall, participants discussed common fears they had, particularly around bringing COVID-19 home to their loved ones and families, or having to mitigate altercations around mask enforcement. These fears were often accompanied by sentiments of feeling unprepared or unsupported by their organization. So organizations should consider providing additional training or additional resources to help support their workforce while managing these compounding threats, particularly. Future research, our hurricane group has kind of already started it. So I would suggest if you're interested in kind of what we've done since this project, as it data collection did take place in 2020. Zach Carr and Tracy Gates have some posters in the back. Posters 9 and 11 both kind of discuss the ongoing research with this group. For practical suggestions, one of the more difficult but necessary changes that organizations should consider is fostering a workplace culture that prioritizes their workers' health. Currently, participants indicated that most cultures within emergency management discourage workers from taking breaks, taking time off, or discussing their mental health at all. So critically, additional resources or communication of available services are needed to actually provide mental health services to emergency management personnel. This could look like access to telehealth for kind of on-the-job response, access to mental health, or access to in-person mental health professionals. I'd like to give a quick thank you to my team. My co-author on this PPRT grant was Kayla Jones, who unfortunately couldn't be here today. I'd also like to thank Renisha Blake at Old Dominion University for helping code, and then big thanks to Dr. Kelsey Merlot and Dr. Jennifer Marshall for all of their guidance and mentorship on this project.
This will probably be for your entire group to answer because this is just something I'm not aware of. So when you talk about these shelters, are they permitting animals into that environment as well?
It depends on the shelter. I was able to kind of go see and tour one while there wasn't a hurricane happening. Some of them permit pets and animals, but a lot of them don't. So it kind of goes shelter by shelter.
And so follow up to that, is that something that you could look at within your data to see if there are different themes based on which shelters might permit animals and which ones do not?
Unfortunately, our participants didn't really discuss animals in shelters, but that was something that I thought of as kind of an outsider to, hurricane sheltering and public health was, having people's pets might be kind of a comfort in these stressful situations.
I mean, even for the workers,
Yeah.
too. It's a population we actually miss. We think about the evacuees that need to shelter, but the workers having something that they're used to support system, their family or the animals. So
Yeah, exactly.
comment.
A little fur therapy helps everybody.
Hi. So when you talked about one of the things that people mentioned when they talked about organizational support, you talked about a lack of training. And I was wondering if you can go into some more detail about what specific training people felt like they were lacking or like where they could feel like more resources need to be put there.
Yeah. Participants discussed how a lot of the people who were either volunteering or working in a shelter, their full-time job wasn't emergency management. People who work for any sector of the government could kind of be called in. So it's kind of within that of we're having a workforce who this isn't their full-time job, so they're not really properly trained, and they're kind of expected to just kind of go with the flow and catch up. So again, it kind of varies from shelter to shelter. It seems like there's a disconnect in communication, but kind of like a broad, just more training on what's expected and what tasks they need to complete was called for.
Thank you.
Yeah.
Going back to Dr. Fletcher's contributions, top of the day here, what do you think the role of the presence or lack of presence or lack of leadership in the workplace relative to providing a sense of value and worker contribution in terms of the overall perspective that you're sharing?
Yeah, it really depends on the type of leadership that's given. I'm not super familiar with the leadership research as it pertains to sheltering events, but I believe that, my personal opinion, having a strong leader to kind of guide workers would aid in this scenario, if that answers your question.
Right, it's tricky because the first line responders are leaders in the community, but they are also working as a group, and there's leaders that marshal their capacity as well.
Exactly, and with so much turnover, it's hard to kind of pass down that knowledge that's accumulated over years and years of expertise and on-the-job work.
Thank you again, Katrina Konen, for that contribution. Good job. Nathan Poole, we have one more contribution, one more talk this afternoon, it's really great to either be right after lunch or the very last talk of the day. You really have a great challenge, but it's a great opportunity. And that opportunity really is in this audience. It's us. So Nathan is a PhD candidate in industrial systems engineering, right? A lot of different resources and capacity and expertise coming together in this room. Nathan's going to be talking about evaluating the effect of creep and cyclic loading on human tendons.
Oh, hi everyone. I'll show you in a minute, but this is kind of an inopportune time for me to present, but we'll get to that in a moment and you'll see why. I'm gonna go ahead and start a timer here. So, like I said, like was mentioned, I'm a PhD candidate at Auburn University in Industrial and Systems Engineering, and my focus is occupational injury prevention. Initially, I was a biologist, so kind of what in the heck am I doing in engineering? I'll show you in a minute. And I hopefully will be graduating soon. Fingers crossed, but that's how it goes sometimes. This has been a very large multidisciplinary project. I've been working with VCOM, so Virginia College of Osteopathic Medicine students. There's some of their faculty, as well as a neurobiology student at Stanford currently for his PhD. So there's a lot of different people to thank for that, and as well as the Sunshine ERC, Dr. Bernard, and Ms. Friedman for helping with the funding for this study. Let's just go ahead and get into it, skip that. So there's some definitions I want to go over with you all so we're all kind of on the same page, and there's maybe a few more along the way. So what is cyclic loading? When I'm talking about, you could think of a Coke can. So look at a regular soda can, think about that top. Some, as kids, they'll bend that thing back and forth until it breaks. So what they're essentially doing is cycling that soda top until it fails. And so it's a repeated loading of an object, worker, depending on the context. Now, creep loading, you can think of a spring, and if I put a weight on the bottom of that spring, and over time, that weight slowly will begin to stretch out that spring. Residual strength is load of a damaged material sustains without failing. So you can think of that spring being expanded, again, with that weight, and instead of letting it fail or completely stretch out, I take that weight off of it. Then ultimate tensile stress, or strength depending on the context, is the maximum stress a material can withstand under an applied force. So background and function, a little bit about tendons. So it's a form of connective tissue, connects muscle to bone, really important for movement, and it's really all about location, location, location with tendons. Their function, structure, everything will be based on where they're located. So shoulder tendons will be different sizes compared to ones that are in the legs, compared to the ones that are in the hands. It's been noted that they are similar in tensile strength to that of bone. So highly elastic material, but also very, very strong. And as I mentioned, function will depend on the location, and they do have some capacity to heal. Other things, so over time, tendons can become damaged, unfortunately. There's a lot of factors that go into that. It's a whole range of potential risk factors, but as mentioned earlier by one of my colleagues, something like a musculoskeletal disorder can develop. So musculoskeletal disorders are disorders that affect the musculoskeletal system. Sometimes they can lead to pain, inflammation, discomfort. Generally, you can think of some type of loss of function or reduction of function. Other common things, so you can think of tendinitis, tendinosis, tenosynovitis, golfer's elbow, and tennis elbow are some other common ones. How am I doing on time? Good. So there's a lot of evidence that suggests the development of MSDs may be due to fatigue failure. That's typically a process or an idea that we think of with metals. So kind of why that's applying to tendons? Well, simply tendons are essentially an elastic material that acts similar to that of other materials. Researchers have noticed that, have classified it as a unidirectional elastic composite. So it has similar properties to that of other elastic materials. There's also currently lack of knowledge of the significance of the cumulative interaction, the effect of combined creep and cyclic loading. There's also lack of knowledge on potential of impact of creep loading on the tendons. So there were three main goals of the study altogether, so three separate experiments. One focused on cyclic loading, second for creep loading, and the third, which I find the most interesting, is sequential load ordering, and that can be a little confusing, so I'll explain that here in a little bit. So we had altogether 160 profundus and superficialis tendons from 10 donors. For this, we pulled an 8 centimeter region within the carpal tunnel. For this, there's also a series of an Instron microtester, a hydration bath, grip, and I believe I have a few pictures later on. Some interesting things involving a CT scanner and some 3D printed parts. These are the locations of the profundus and superficialis. Hopefully that's big enough so everyone can see it, kind of why that matters. So for those who don't know, you can think of the, make sure if I remember correctly, superficialis as the wave and the profundus as the grip. Apologize if I've gotten that backwards. So it kind of helps us to grip things. Okay, materials. So as I mentioned, we had 10 donors. Please note that there were 2 donors, unfortunately, with type 2 diabetes as a secondary cause of death, which may have some impact on their function or the ability of some of their properties. I haven't been able to locate research that tells me specifically, okay, this tendon for people with type 2 diabetes is this percentage of reduction in function. Or for those who smoke, it's this percent reduction in function. All specimens, 20% were frozen at -20, so that's roughly -4 Fahrenheit. And no, of course, MSDs or diagnosed for any bone joint conditions. So warning, so here's what I mentioned earlier about me being weird, it's kind of weird me being last. So for those who have queasy stomachs, you may want to look away at this point. So let's just get into the dissections. So this is a dissection example. Yeah, so please look away, and I apologize. It was not my fault, this being right before dinner. So either people are going to want to gag or they want to go to eat something after this. I've gotten both responses. So this kind of shows the location. So all the yellow is fat, so please ignore that. What's held up in the picture, I believe, is one of the profundus it's either the profundus or the superficialis for one of the donors. Okay, I'll go ahead and skip that. So after the dissections, we get into I'll save everyone the gross images. That's it. That's all the really gross ones. I promise. Well, maybe. I don't. Well, we'll find out together again with another warning. I'm kidding. So after we did the dissections, we custom made 3D printing trays in order to put them into a scanner so that there are several different ways to measure cross-sectional areas for tendons. Cross-sectional area is important. So you can think of an old rubber band and how it kind of looks tapered as it gets older. That area, the smallest area of that rubber band is more than likely going to be the weakest and what's going to take on the most force. So when we think of tendons, sometimes they can become like that over time, and they degrade over time. They can for multiple conditions. So we look at that area because that's the biggest indicator of how much force that tendon's going to potentially be loaded on. So after we stick them in the trays, we'll end up using a CT scanner. And it looks like this. Yes, there's more than 8. There's also 2 extensor tendons in there as well that we're using for some preliminary studies. From here, we developed code that would try to analyze the image to measure the cross-sectional area for each tendon. And this was along the length of them throughout that whole tray, and there were about 10 trays altogether, 1 for each donor. As I mentioned earlier, so in order to do this type of testing, I wanted to try to mimic the human body conditions as much as possible. So we're using a hydration bath with saline to try to mimic the human system, as well as pneumatic grips to help hold the tendons. And that leads into another issue with the tendons being stable in place for testing. Luckily, I was able to work with a research group in Germany, so I've had to go virtually back and forth between different countries for this. We're using 3D printed clamps. These clamps through research, have shown to reduce the damage to the tendons caused by the grips themselves, and it evenly displaces the surface area of the tendon It helps get better data. Okay, so why am I doing all of this is kind of simply explained by this graph. This graph is something very similar to what you would see with metal. The regions for failure, you typically have a toe region, so it's this very front flat line here. I'm sorry for those in TV land who may or may not be able to see the pointer. As it increases in load, so it's getting pulled tighter and tighter, it goes into a linear region. So that's the region that's straight up diagonal. So it's increasing load over time, it's getting more and more load. And then in between the next two, there's this other small one, this is a plastic deformation region. So it gets to the point where it's starting to take on damage, things are starting to happen, it can start to weaken a little bit. This one, unfortunately, doesn't really have that region. And then you get into the third and final region, the failure region, so it just goes. And this whole chart by itself is consistent with other metals and just other tendons that I've seen studies for, this is just more evidence supporting that fact that tendons fail similar to that of other materials. So from the study itself, the Instron, there's a lot of different testing parameters that you can use. Strain, for example, is a big one that has been used, but you need a lot of prior testing experience for that, which I did not have. So instead, we used load control and different methods for that and different levels to determine what levels of UTS, or that ultimate tensile stress, the tendons would be tested at. And that was done from the previous slide, 1 millimeter per second. And they're just pulled to failure, and then we use the averages from that data to set the rest of the tests. The cyclic loading, as I had mentioned, so I had 16 tendons randomly sampled for 4 different levels of UTS. This allows us, using this an average UTS lets us normalize the tendons, so we're able to kind of remove control for some variability. Frequency of 1 hertz. 1 hertz is a typical movement speed for the hands compared to, I believe it's either 2 or 3 hertz for normal walking. Load control, as I was talking about the system and how it works, you have to have some kind of control method to keep things standardized. Tests were performed to 48 hours. Why 48 hours? In case someone wants to know, I have to share the machine with other students, so I have to play fair and share. So, and that was the agreement that I got approved. Weibull is also is one of the analysis methods, and I'll get to that shortly. So creep loading, same idea. Instead of 1 hertz, we're doing 1 to 2 second ramp up period, and that's just the time it's going through that linear region and taking on load at a fast rate. The analysis for that is survival analysis, specifically Cox proportional hazards, and I've got a graph of that here. Sequential load ordering, okay, so this is the slightly confusing part. It's essentially exposing the tendon to different orders. So one tendon would be set up for cyclic loading, and then immediately after a time of rest, go into creep loading. Same tendon in the same machine at that time, and it repeats that sequence until failure, and vice versa. Now, why this is important is because during a normal workday, you're just even like me standing up, you sitting down, you're either experiencing some type of cyclic loading. For some people who are playing with their phones, cyclic loading with the fingers, swiping, or even just sitting, our backs can be experiencing creep loading. That stretching of the muscles and tendons and different things to keep our bodies up. Like right now, I have back muscles that are experiencing creep loading. And with that, for these, we're testing at 25 and 55%. The analysis is crossover design, and that's a design typical that in different medical studies for chronic illnesses. However, it's proving to be an interesting method of analysis for this. Here's another definition. So we're talking about reliability. I mentioned Weibull analysis. This is all part of reliability analysis. So in engineering terms, think of reliability as it is the expected lifetime of a product, of an object, within its expected normal testing parameters. So I can't take my Nissan Sentra and go mudding with it and expect it to survive. Because that is not what it was made for, so that would definitely not meet that definition. In some sense, tendons can also have that idea. And this is the results of that. And this is basically saying simply that we can look at that first one. So 1% reliability is 1% of the tendons would be expected to last that many cycles. However, this does not take into account the healing aspect. That's something that has to still be further studied. So this is the tendon ex vivo. And then from there, so the more UTS you add, the less likely it is to survive. How am I doing on time? Still doing good. I do apologize. Minitab is not very kind, so I did not know how these would pop up. So it looks like they're actually decent, pretty big. Yeah, they're okay. This is the Weibull analysis plots for these, so it's just showing a model. It's the model that predicted these values. Yes, Weibull analysis for the 3 points, yes, there's only 3 data points because I believe I had a few tendons that survived the 48-hour period and they became censored. However, this is kind of what Weibull is really good at doing. At least you need at least 3 data points and it can give you a fairly decent model. Of course, more is better. And that was for, what was that, 40, 60, and then here is the 80%, and then I'm also able to plot all 3 of them together, but this is just telling me and screaming at me more data. Maybe eventually when I can get more funding. Money, money, money talks. Okay, so this is the survival analysis plot. I did not have time to really get into the analysis, but I wanted to at least show these plots. Now how this is essentially a Kaplan-Meier curve. So each stair is an event. So each stair is a failure. Now, looking at this, the 60 and the 80% are kind of flipped. I'm still trying to figure out why that is. It could just be variability of the tendons. It could be how the orders were randomized. But the 80% would typically fail before the 60% instead of the way it has been. And yes, there's only 2. You can only really see 1 or 2 events in the 60% because 2 failed within like 1 or 2 seconds less than a second, instead of the 172,800 seconds for the 48 hours. The one at the very top is the 20%, so it did not fail within that 48-hour period. So I have to censor that data, and it can be used for residual strength testing. So MSDs are still a prevalent problem. Being able to better understand them and how they develop can help influence further research and help hopefully reduce their prevalence altogether in the workplace. And as I'd mentioned earlier, more studies are needed and encouraged. So the healing process and trying to determine a rate of healing for tendons, hopefully using some of the data I've collected now to improve further risk assessment models. And I think that's all I have.
Where do tendons get most abused that this inspires you? Which sectors, which work sectors do you think that this research applies to most, or that you were thinking of as you were engaging in it?
So it's typically manufacturing setting. That's what we really focus on. But the idea of it can be applied to any industry. If there's any industry that requires upper extremity work, risk assessment models can be applied to help benefit that. So hopefully we can improve that, and by adding CREEP data that may not exist in pre-existing tools.